In this lecture, I'm going to talk about the normal curve and the empirical rule. So in the past, I've used bar graphs to display discrete data, like the graph below, and I've used histograms to display continuous data, like the graph below. You can see the difference between a bar graph and a histogram is really whether or not the bars are touching or not. So the distributions of many or most continuous variables will ideally follow the shape of the normal curve. Now the normal curve looks something like this. Now I'm going to label it where on the bottom we have values, and then on the y-axis we have the different probabilities associated with those values. So I'm just going to make up some numbers here. You can see that 4 has the highest probability, that's in the middle. So those are some values I made up. And in this graph, in a normal curve, a perfectly normal curve, the mean, median, and mode all exist at the center. So for this curve, 4 is the mean, median, and the mode. Remember, those are measures of central tendency. So below the mean, median, and mode, 50% of the scores lie, and above it, 50% of scores lie, because it is exactly in the middle of the distribution. So the graph changes direction at inflection points. In these inflection points, when you're one inflection point from the mean, it marks one standard deviation from the mean. So I'm just going to draw some lines here to mark the standard deviations. So for like 3 and 5, if you're at those, you are one standard deviation away from the mean. If you're at, say, 2 or 6, you are two standard deviations away from the mean. So now I've marked that on the bottom, where we have the mean on the bottom, and then you can see as we're going up 1, 2 standard deviations, and down 1, 2 standard deviations. So now the empirical rule. The empirical rule states that 68% of all the values in your distribution will fall within one standard deviation of the mean. So for this distribution, you would expect 68% of all the values to be between 3 and 5. Now it also states that 95% of the values will fall between two standard deviations of the mean. So we would expect 95% of values to lie between 2 and 6 for this distribution. And while I don't have it marked on my graph, also another part of the empirical rule is that 99.7% of all values will fall within 3 standard deviations of the mean. So almost all the values will always be within 3 standard deviations of the mean. If something is outside of that, it'd be a very rare event, right? Because it's very unlikely for something to be outside of 3 standard deviations. So I'm going to take that off, and I'm going to put in these probabilities. Realize that using what I just taught you, we can actually figure out the probabilities that lie within these areas. Like, for example, we know half the scores have to be below 4, and half the scores have to be above 5. We know that 68% of the scores are between 3 and 5, so I'm just evenly splitting that up into 34 by 34. So using this empirical rule, we can actually find out what area is associated between different distances without doing, things like complicated calculus, which we could do, but it would be a lot of work for every distribution we have to work with. And that is the normal curve and the empirical rule, which you construct for continuous random variables.